What's up, Cal gang? All right, so we got this problem here, and it's gonna be a bit tricky. So we're gonna do it. We're gonna do great. So let's get started. So basically, you have this cube. Let me go back to the homework. You got this cube that's in a vat of water and then glycerin. How do you pronounce that? Hold on, I'm gonna watch this. That's gonna be funny.
Glycerin.
Glycerin, yes. I am very good at English. Glycerin, okay, so you got glycerin, and you don't know how much is in which, and you're trying to find the ratio. You're trying to find what fraction of the volume is below the surface of the glycerin. So let's go ahead and get started with that. So we know that it's 40 centimeters deep in water, and then it says that there's 60 centimeters here, not gonna be necessary. So let's go ahead and label this. So this is height 1, and then this is height 2. So height 1 is in the water, height 2 is in the glycerin. And let's see, let's draw a force body diagram, because we always want to draw force body diagrams, right? So what's pushing down on the block? Well, it's going to be the force of gravity, right? But then forcing up on the block is going to be the force of buoyancy from the glycerin. But then you're also going to have the force of buoyancy from the water. You have two separate buoyancies because you're in two separate liquids. The buoyancy is going to be how much of the volume is within each one of those categories. So we can go ahead and put this, because it's in equilibrium, the block isn't moving. We know that the sum of forces in the y direction is equal to 0. That's what it's in equilibrium means. So you can say that 0 is equal to the sum of all these. So it's going to be force of gravity minus the force of buoyancy of the glycerin minus the force of buoyancy of the water. It doesn't matter which direction you take to be positive or negative here, as long as they're going to be negatives pointing one way and positives pointing the other way. So I'm going to go ahead and put them on this side. So you're going to get force of buoyancy plus force of buoyancy. I'm just going to keep it like that, is equal to force of gravity. Let's get started with this. All right, let's expand. Okay, so buoyancy, force of buoyancy is equal to the density of the liquid times gravity times the volume of that substance in the liquid. So this is going to be for glycerin, and then this is going to be density, so this is density glycerin, this is density H2O, gravity, volume in glycerin, and that's equal to, mass times gravity, of course. So you notice we have gravity in all these, we can go ahead and cancel that out. Gonna make things a bit easier on us. So we have these densities, right? What are we trying to find? Well, we're trying to find how much is each. Basically, we're trying to find the volumes because we're trying to find, how much height is in each one. So how can we express these volumes in a more meaningful way to us, right? Well, we have the side length, right? Let's look at our cube like this. Let's redraw this in 3D, right? So this is 0.2 meters, 0.2 meters, 0.2 meters, right? But then we also have this dividing line. We don't know what this is. So we can say that this is H1. And we can say that this is H2. So we want to find the volume of each one of these separate things by themselves. So for H2, we can say that it's going to be the area of the bottom, right? So this area of the bottom is going to be 0.2, I wrote this wrong, these are zeros, extras, forget about that. Okay, so it's going to be 0.02, right? That's the length of one side, and if you're trying to find the area, square it. Then you have the area of this bottom. Then if you multiply by a height of 2, you're going to get the volume of just the part that's in the glycerin. Same thing for height 1, right? If you want to find the volume of this thing, you're going to take the length times the width, so 0.2, or 0.02, times 0.02, so squared, and then times the height of 1. So this is, volume of the H2O, and this is volume glycerin. Hopefully you can see that. Yeah, it's not too bad in the glare. Okay, so basically, let's plug this in. So density of glycerin is 1. Actually, let's go ahead and not do that yet. So density of the glycerin times 0.02 squared times height plus the density of the water, and then 0.02. I forgot to put which height this was. So this height, if it's the glycerin, it's going to be height 2. That's what we specified that as up here too. So then this is going to be height 1, because this is the density or the volume of the H2O, and that's just going to be equal to the mass, which we also have. So what are we trying to do? We're trying to get these heights by themselves. How are we going to do that? That's a good question, actually. That's something I need to know. Okay, we want... What are we trying to find? What is the fraction of its volume below the surface? So we want... What do we want? Okay, so we want the average, I guess. So we just want to find one of these numbers, basically. We want to single it out. How are we going to do that? That's a good question. Let's do it. What am I thinking right now? Okay. Basically, this isn't enough to solve it, right? We have two unknowns, and we can't solve an equation with two unknowns, right? We're trying to find the height of both of these. How are we going to do that? Well, we can write out one more thing that is going to help us. So going back to this cube, we know that its volume is going to be equal to 0.02 cubed, right? That's the total volume of this cube. It's length, width times depth, 0.03 cubed. But we also know that the volume of this cube is going to be equal to this portion plus this portion, which we defined with these two volumes. So we can say that the volume, 0.02 cubed, is equal to 0.02 squared, height 1, plus 0.02 height 2, or squared height 2. And I guess this is pretty logical. It's going to be 0.02 is equal to h1 plus h2. That also makes sense because I guess we can look at it like this, right? Height 1 plus height 2 is equal to the length of this, or the height of this. So yeah, this equation makes sense. I kind of showed the dumb way of doing it, actually. I don't know why I did that. Okay, so basically now we have two equations and two unknowns we can solve now, right? So let's solve for h1 just because you can. So 0.02 minus h2 is equal to h1. This is going to be very valuable because what we're going to do is plug this in here, right? Let's do it. Okay, so density, glycerin, times 0.02 squared, height 2, plus density of water, 0.02 squared, height 1. We're going to go plug this in, 0.02 minus height 2 is equal to the mass. Look at that. We only have one unknown now. So what I'm going to do is I'm just going to plug in the numbers, and I'm going to assume that you guys can solve it from there. Because I'm not really trying to show how to solve this. I'm already 7.5 minutes in, trying to keep it short. So density of glycerin is going to be 1260, 0.02 squared, height 2, plus 1000 is the density of water, 0.02 squared, 0.02 minus h2 is equal to the mass, 9.20 times 10 negative 3. And if you solve this for h2, which is what you need to do, you're going to get that height of 1 is equal to 0.00846 meters, or if you want that more logically, 0.8446 centimeters, which makes sense. If it's 2 centimeters, that means that a little bit less than half of it is in the water section. So basically, if you want to, you can plug this back into this equation. So it's going to be 2 minus 0.008, or I guess 0.02 minus 0.00846 is equal to height of 1. So height of 1 is going to be equal to 0.0115 meters, or 1.15 centimeters. So now we have these 2 centimeters, right? This is not what we're asking for, though. Do I have any space left at all? I guess I'm going to have to erase. Okay. We're going to go right here. All right, so if you want to find the percentage of how much is below the surface, you're going to have to take the kind of like the average. So if you want to find the percent is equal to how much is below the surface, that's going to be height of 2. Wait, hold on. Oh, I got my heights mixed up. This is height 2. Height of 2, so that's going to be height h2 over h1 plus h2, which we know h1 plus h2 is equal to 0.2, right? So this is going to be equal to, if you divide this number by 0.2, you're going to get 57.7%. There you go. That's your final answer. So this is a pretty long problem. I'm going to try to cut the video off now because it's long. But yeah, thanks for watching. Good luck on your physics homework, guys. Stick around if you want some more physics problems, and I'll help you solve them. So yeah, thanks.